Hello and welcome to another tutorial. We are now going to start looking at the GraalVM native image, which, as I mentioned before, it relies on the default platform toolchain to compile your Java application into native executable binary. In that way, the startup of your application becomes very fast. The performance of your application, of your Java application after compilation, becomes very similar to a C++ application. But we know that the developing a Java application is much faster than developing a C++ application, because you don't need to worry about memory management, garbage collection, this kind of stuff. All right, GraalVM native image. We can use GraalVM to convert our Java code into a command line executable binary. And when I say Java code, it means the class files, right? .class files, because GraalVM basically GraalVM works on the class file. So you write your Java source codes and then you use the Java compiler to convert your application into the class files, right? And then you can test it by running the JVM. And once your application is done, you've finished testing. Now you can invoke the native image from GraalVM to compile your class files into an executable binary. GraalVM has the native image tool. When you download it, you have to it doesn't come as a standard part of the GraalVM. You have to go ahead and download it. GraalVM provides a command line tools, so you have to manually install it using a Graal updater. So Graal updater command line, or GU. So GU is a command line tool that comes with the Graal. And again, the GraalVM is essentially a JDK, which means it has a home directory and then a bin directory that has all the Java, C, etc. But it just has more extra development tools like the Graal updater, and then you can install native image. So it's essentially something that is built on top of a JDK, right? And I believe it comes with the Open JDK version of the Java. So you can download the free GraalVM Community Edition. So it has a free edition, which is Community Edition, and then Enterprise Edition, which has a little bit more features. For our use cases, in terms of just compiling our Java application to native binary, the Community Edition is definitely enough. So you can just go to graalvm.org/download. So let me just open it up here, and as you can see, we have this Community Edition, and then you want to click on the downloads. And GraalVM has binaries for any platform: Linux, macOS, and Windows. And for Linux, x64 architecture and then ARM architecture is available. For macOS, both x64 and ARM is available, because Apple switched to M1 processor, which are based on ARM architecture. For Windows, only x64, meaning Intel and CPU, Intel and AMD architectures are available. So you can click on download, but it says that if you are on macOS, after you download it, in the recent version of the macOS, like from Catalina and later, you have to remove the quarantine attributes that basically the macOS sets for untrusted files. So when you download this, you want to copy and paste this to the terminal, basically path to the GraalVM folder. You have to substitute this, and then sudo x attribute -r-d com.apple quarantine, and then all the GraalVM folder, right? So this is a little bit of, so macOS in the recent version, it adds more security to the files, make sure that the files are not malicious, etc. So for example, let's say we want to download and I recommend you basically download the JDK 17 version, which is long-term support. It has nice Java features. So we're going to look at the macOS AMD 64 and then click on the download. It goes ahead and downloads it, and then you just basically it's a zip folder, right? And it's about 500 megabyte, and then after that you unzip it and move it to your /library Java virtual machines, right? So I'm going to wait for this to finish up. So it's just a zip file, and you unzip it and move it there. But before using it, you have to run this command line in macOS if you are using Catalina or later, to make sure that the operating system doesn't flag these files as malicious, right? You have to. So I've already previously installed this, so I'm going to go to folder library Java virtual machines, and as you can see, I have GraalVM Java 11 and GraalVM Community Edition CE Java 17. And it's very similar to how the JDK is organized. So it starts with contents and then home, and then it has a bin directory, and then JMods. These are obviously JDK modules, Java base, etc. So it's built on top of a JDK. If we go to the bin, you see it just has extra command line executables that are in addition to the standard JDK. So all these are a standard JDK, for example, jar, Java, Java C, Java doc, Java P, for example, JCMD, Java command, JFR, Java flight recorder, JDB, Java debugger, etc. But then we have GU, which is Graal updater, and using this GU, you can actually install more modules that are specific to GraalVM, like the native image, or for example, Graal Python. You can use GraalVM, which is a Java virtual machine, to execute Python scripts, right? Now, obviously, it's going to be slower than if you just actually install the Python VM. Remember, Python is also something that launches a virtual machine and executes your Python code. But then you can also interpret the Python scripts using GraalVM. And I believe it can benefit from the JIT compilation that GraalVM provides, because it's a JVM. Java virtual machine does come with a JIT compiler, whereas Python virtual machine by default doesn't come with any JIT compiler, right? It's always interpreted. All right, so I'm going to go ahead and basically open up a terminal. All right, and then what you want to do is actually just like the Java home environment variable that we set to this home directory, you can define a Graal home environment variable. So if I say echo Graal home, Graal underscore home, it says library Java virtual machines, GraalVM Community Edition Java 17, contents home. So this directory, right? And inside the directory, we know that there is a bin directory. So if I want to see which version of the JDK this Graal home is from, I can say Graal home, Graal underscore home /bin /Java - version. And it tells me that the Graal VM, this version 17 Community Edition, is built on top of the Open JDK 17. So it's not the Oracle JDK, right? So if I type Java - version, it tells me that it's the Java hotspot, which is Oracle VM. And as I mentioned before, I've also defined the Java home. So I've pointed my Java home environment variable to JDK 17, which is Oracle JDK, and the Graal home is pointing to the GraalVM home directory, right? And then so basically, and then I said that inside the bin we have this Graal updater. So what happens here is that if I say Graal home /bin /gu - version, and then it tells me that GraalVM updated. And if you want to install native image, you want to say gu -install or -- install native -image. And okay, so I think it doesn't have let's see. So okay, so we shouldn't add this --. And it tells me that so once you run this command, so you run the first time you download this, you have to install the native image using the Graal updater, and then the action is install native image, and then it reaches the Git repository. It tells me that native image is already installed, so it knows that I have installed native image and it's already up to date, so there is no further action is required, right? And then after that, obviously the native image is put in the bin. And in fact, if you look at these are not the actual files. These are aliases or symbolic links, right? In macOS we call them aliases. In Windows, we call them shortcut, right? To the operating system, there is no difference between these. Actually, We have to clean. There is no, to the operating system or to the terminal, there is no difference between a symbolic link or a shortcut to a file and the file itself. Because if I drag and drop this, it tells me native image, right? But this is a shortcut. And if I say -- version, basically the operating system and the terminal realizes this is shortcut and it knows how to find it, right? So if I right click show original, it tells me that the actual executable binary of the native image is inside the GraalVM contents home. It's inside the lib. And SVM means sub VM or substrate VM, substrate virtual machine, and bin. So it's there, right? So I can drag and drop this and then -- version. So the native image one that is inside the bin directory or even Graal updated, right? These are symbolic links or shortcuts, but to the operating system, shortcuts and the actual files, they're the same thing, right? That's the meaning of the symbolic link or an alias. But for example, this Java one is actually the actual file, right? Now what you can do, you can actually create aliases. For example, make alias. I can create an alias or shortcut for this Java and put it, for example, on the desktop, on somewhere else. And whenever I execute from there, it's going to basically use this one. So I'm going to make an alias here. Let's call it Java _ alias. All right. And then I'm going to drag it to my home directory. All right. So note that I didn't copy the file. I basically created a alias. This is a shortcut, right? Then if I say Java alias -- version, unknown command Java _ alias, that's because I'm in the same directory. So I have to use the dot Java alias, and is not executable by this user. So chmod +x and then Java _ alias. All right, and now it's executable, and I can say dot Java alias failed to execute process. The file could not be run by the operating system. So you have to do a little bit more for this kind of executable shortcuts, but in general, you can create a symbolic link. So I guess the mistake here is that using right click and making alias, it only works mainly for directories. For files, you kind of need to create a symbolic link, right? And then use those, right? So there's a difference between a symbolic link and the alias in macOS, right? Or the shortcut in Windows. All right, so now we have installed GraalVM in macOS. In the future lectures, I'll show you how to install GraalVM and the native image in Windows and Linux, right? So the idea here is that so we have this native image, and then what we want to do is we're going to say that again GraalVM and then Graal home /bin / native image, and then -- version to make sure that everything works fine. We have the native image installed. All right. So back to PowerPoint, we installed the native image using the Graal updater. The command is graal gu install native -image, and it downloads the native image and puts there. Create a main class in the Java project, reads and parses the command line, which we already created a project. Run native image on the main class, because we said that a class that has a main method is the entry point to the Java application, and then the native image tool can compile that class to an executable binary. At the moment, Java 8, Java 11 are fully supported. Actually, we have to say Java 11 and Java 17 are fully supported. We can use Java 11 or Java 17 version of GraalVM. The suggestion is to use Java 17. If native image is not installed, first try to install it. And there is the documentation or the reference manual for the native image is here. So native image, it has a very, very nice and detailed documentation. Obviously, in the course of these lectures, I will walk you through all this documentation, point out all the important topics, right? So the native image builder or native image is a utility that processes all classes of an application and their dependencies, including those from JDK. it statically analyzes these data to determine which classes and methods are reachable during the application execution. Then it ahead of time compiles that reachable code. This is the static compilation that I mentioned before, and data to a native executable for a specific operating system and architecture. This entire process is called building an image, or the image build time, to clearly distinguish it from the compilation of Java source code to bytecode, which creates the class files, right? Using Java compiler. So install native image. Native image can be added to the GraalVM with the GraalVM updater or the GU command line tool. And we said that by default native image is not included in the bin directory, but you can say GU install native dash image. And this GU, there's a symbolic link in the bin directory of the GraalVM. After this additional step, the native image executable will become available in the Java home/bin directory. And basically, this Java home assumes that you're pointing your Java home also to the bin directory of GraalVM. My recommendation is that to additionally define this Graal home/bin. So always use Graal home/bin so that you always indicate that this native image is actually part of the GraalVM, not the actual JDK, for example, Oracle JDK. So -- version. Prerequisites. So later I will show you on, for example, if you try to install this on Linux, you kind of need to install a few extra libraries that the native image requires to compile your Java application. On macOS, once you install the command line tools, everything comes by default. So there is no additional thing is required. Let's close this terminal. Let's head back to our Eclipse. If you recall, we had this Hello World application, and then this had a dependency on the car, and then a dependency on this machine. These were in different directories, but none of these classes is part of a package. And we said that if we open a terminal here, and in my bash rc file, I've already defined the class path, right, for this project. Test3 directory, test directory, and test2. So, and then let's just compile Java application, our Java application, to make sure that it's up to date. Yes, and it can find all the dependencies, car and then machine. That's because Java looks at the class path. And then we can also run the hello world.class. All the dependencies can be found using the basically the class path environment variable for this particular application. So everything is set. Now I'm just going to quickly compile this application. Note that I'm going to invoke the native image on the hello world that has the main method, right? So let's see. Let's spread this. So we're going to say Graal home, and then /bin/native image, and then we're going to say -cp, and then pass the environment variable class path, right? And then hello world, right? So, and then terminal replaces this with all those directories, and therefore native image. Remember, native image is also on top of the JVM, right? So it's associated with JVM, so it has to know where to find the classes that your Java application needs to successfully run, right? So it still works with the class path, right? And then we run this, it starts the compilation. The compilation has a couple of phases. In the future lectures, I will show you and walk you through all the phases, all the details here. But the first one is just gives you the information that it is able to successfully run the GraalVM native image command line tool. And then it also gives you the version, GraalVM 17. And then it tells you how many classes it needs to successfully compile so that your application can run. Building universe, parsing methods, inlining method. This means the static compiler of the native image is trying to optimize method calls, right? You know that inlining is easier. And as you can see, it was pretty quick, and it tells me that where it actually puts the final executable, right? So basically the idea here is that now we have this hello world, and we know that in macOS and Linux we have to say dot, because hello world was put in our current working directory, and it works. As you can see, this name, which was based on the system property, is null, so we can say hello world. and then -d name equals Bob, and now name is Bob. So once you compile your Java application to native executable binary, you can still use -d system properties and your application still works fine, because your application has a JVM embedded in it, right? But that it doesn't mean that the JVM is separate application. Everything has been compiled to a native executable binary, right? And then the other thing is that we can also add command line arguments, and all of them are going to be here. So all of these are command line arguments, and your native executable binary differentiates between the system parameters, the ones that start with -d, and then the ones that don't start with -d, which is very nice, because then it gives you a degree of freedom so that you can quickly take advantage of system.get property and then use this to configure your application. And then the command line arguments, the rest are passed as this string array. All right. So I just want to again mention that if one of the strings that comes after your native executable binary, right, it starts with -d, it's not going to be passed to this string array of the main method, right? It's going to be passed to the system properties here, and you have to access them using get property. And it already knows that it has to be a key value pair. You specify the key equals value, and it returns a string which is value. If the string comes out as null, it means that this value is not set for this key in the terminal, right, at the time where we run our Java application. So I hope you enjoyed this lecture and have an introduction to native image. In the future lectures, I will give you more details. So please stay tuned, and I'll see you in the next one.